Hello, this is Swapnil Astakala, and the video might be little fast because I need to cover 4 hours video in 10 minutes. So the entire project is in single file, single Python file, and I have done it in Jupyter Notebook. This is a fresh file which I have extracted from the zip file which I submitted in my IC assignment. So so again, to be clear, I had restarted the kernel by clearing all the outputs. So this is a fresh file now. So I had run all the cells at the same time. So these are the basic imports which are need to be mm, installed previously before running this project, which is NumPy, Pandas, TensorFlow, Seaborn, and Matplot libraries. For data processing, I had those are three different folders like test, train, and validation folders. And the data is about 1 GB file, which is around 5,000 images, just express images. So those are need it takes time to upload the images since it is a big file. Once the data is loaded, the next major task is to be all the images need to be augmented. So the process called image augmentations. So basically, if we observe the raw X-ray images, the raw data set, you can clearly observe in this images are not in same shape. Same size, and some are tilted to left side, some are tilted to right side. So basically, to avoid this, we need to perform image augmentation, so that the image augmentation basically brings in same size. So with same size, which is of 224, as I assign in this program. So all these images are of 224 by 224 size. Model 1 in this project is which is convolution neural network, which is built from scratch. So we need to train according to our data set. We need to build our model and we need to train our model. So this is the model structure outline. So you can clearly observe that I had built it in like three blocks with convolution and max pooling layers, and followed by classification part, which is flatten and dense layers. So we can find one of each 16 layered convolution and max pooling layers, and two of each convolution and max pooling layer with 32 and 64 layers, and all the flatten layers and dense layers are of 128 and 64 layers, and one sigmoid layer. This is a summary of the above model. So here we can clearly observe the parameters which are parameters in a sense is the weights which are which are assigned to each layer. So that so our total parameters are about 283,009, and the trainable parameters are, so all the parameters which are implemented are trained. Next major step is to, need to be performed is we need to fit the model by running epochs. So it took about 10 epochs in this model one. So the following chart illustrates about the history of those epochs in terms of loss, validation loss, and accuracy and validation accuracy. So after implementing this model 1 on the test dataset, we had achieved about 92.46% of accuracy in model 1, which is a very good accuracy from the which is learned from scratch. So followed by there is a confusion matrix and classification report, which is clearly illustrates with what percent of it predicts correct, and what are the wrong cases. So there are 9 random images that are visualized on test dataset, and followed by two images of both pneumonia and normal cases with different images. So I had loaded it and checked it which percent does the model predicts the case. So the model 2, which is transfer learning method, and the model used in this pre-trained model used in this network is ResNet 152v2. So as it is previously trained network on another dataset which is called ImageNet dataset, we need to use this pre-trained network and convert it to as per our model. So the total parameters are about 58 million, and trainable parameters are just about 2 lakhs, 2,70,000. So the rest we need to do it by conversion. So basically in this we need to, after that we need to fit our model to by performing epochs. So each epoch estimated time is about 6 minutes. So there are 8 epochs. So after performing those epochs, we need to monitor the history of those epochs. So after the seventh epoch, I mean after about eighth epoch, the accuracy is about validation accuracy is about 90%, which is good as expected. So we need to perform the test data set. We need to perform our model 2 on the test data set and compare what percentage we might occur. So we had obtained about 91 percentage of by second model from the test data set. The time consumption process in this entire project is during the training our model by performing epoch. So in each model it might take around 1 hour 45 minutes to 1 hour to complete the complete training process in each model. So I had skipped the training process, I mean, which is epoch iterations in each model. So rest everything is clearly stated in this video. The next step to be performed is we need to visualize the classification report and confusion matrix. In three models, it is same in three models basically because the test set used in three models is same. So and then I perform model 2 on random 9 images, and then with each image with normal and pneumonia case. So at what percent it might predicts the image, and then followed by model 3, which is fine tuning technique. Almost it is same as compared with model 2 because the step which we done in this model 3, because we will unfreeze the last 15 layers of pre-trained model, which brings a greater change in this model. Compared to all the three models, fine tuning has obtained a highest accuracy. So the training process is similar as we seen in model 1 and model 2. So there are 9 epochs, and each epoch took about 877 seconds, as we can see in this um, previous step. So after then we need to perform history of those epochs, and followed by we need to implement our model 3 on our test data set. So we need to check it with what percent we might obtain the accuracy on the test data set. So yeah, as I mentioned, 93% we had obtained 93% of accuracy on test dataset, which is highest case in compared to other two models. So then after we need to perform all the same tasks which we had performed in other two models, which is we need to visualize confusion matrix classification report, and followed by we need to test a random images, mm, 9 random images from the test dataset, and let's compare with what percentage the model might predict the pneumonia or normal case, and then followed by each image with different case, which is of normal and pneumonia cases, and then we need to compare the model predictions with other two models. So everything is same process, and finally if we compare these 9 images, we can clearly observe that 95% 99% of testing accuracy with the model 3, which is great. And finally, so here the models of accuracies of three different models. So from model 1 we had obtained 92.4%, model 2 which is about 91%, and model 3 which is about 93%. So this is the project. So this is a short brief about the project. So it took me about 4.5 hours. Complete project it took me about to run 4.5 hours. So the video might be fast. to cover all the things. Thank you.